All right, so now let's say we want to, instead of having a simple frequency distribution, we want to make a grouped frequency distribution. So we're going to use the same data as we used last time. So we've got this data set here. It's got 20 values in it, okay? 20 scores, right? And this was our frequency, but there's a lot here. Maybe we could do better and it'll be a little more, tell a better story, okay? So our group frequency distribution, we want to look at our data and see what's the highest and lowest values. So for us here, we know it's 90, and then the lowest is 80, all right? So we want to set up our table. The difference between a regular simple frequency table and our group frequency table is that we're going to put interval here. And then frequency, we can do cumulative. And then, so actually I should have changed this to say like relative percent, and then we'll do our cumulative percent, our relative percent and our cumulative percent. All right. So some general rules to follow here for deciding interval and width and all of that is choose a width that makes sense for your data. So typical intervals are in multiples of 2 or 3, but if you have a huge data set, a lot of times they will be in intervals of 5 or 10 or sometimes even 15, okay? Sometimes 20. It depends on the width of your data set, so that's why a lot of times people want to know what's the range of your data and then start dividing from there. Then choose a width that gives you between 5 and 10 intervals in the end, right? We want, so, you know, here was 11 different numbers, right? But 11 different numbers, but we really want this to be, you know, less, maybe like 5 or 6 intervals would be a little better and tell a better story, all right? But it's hard to say. So I put together a little example here, and basically the last piece of this, besides choosing a width that makes sense, is make sure your intervals are non-overlapping, okay? And so on here, the 10 to 12, 7 to 9, 4 to 6, right? So 1 to 3, and then we go to 4 to 6, then to 7 to 9. So here, you can't be 10 to, 6 to 8, 8 to 10, 10 to 12. This is wrong. You can't, because something cannot be part of this interval and that interval, all right? So make sure that they're non-overlapping. All right, so I went back and I was like, well, what if we took our original data and we wanted to make a group frequency table instead of a simple frequency table, a distribution, all right? So sure, let's do it. Well, what are our width of our intervals? So our inclusive range is 90 minus 80 plus 1 is 11, okay? And from our previous page, that's why I asked that. And then our exclusive range is 10, all right? Well, so one of the things is if your inclusive range sort of is an odd number, sometimes your intervals won't, end exactly the way you'd like. So that's the only reason that this is important. Exclusive range is 10. So let's say, what if we start with a width of 2? All right, start at the bottom. So we would go 79 to 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. Okay, so that gives us 1, 2, 3, 4, 5, 6 intervals. That's nice. It's good. But there's a lot of odd numbers here, and I don't know, it doesn't appeal to me so much. So what if I tried something else? So what about a width of 3 and I start with the 80? So now I'm like, okay, well, I got 80. So 80, 81, 82, right? So 3, 80 to 82. Then 83, 84, 85. That's another width of 3. 86, 87, 88. 89, 90, 91. All right, so this is a width of 3. Starts with 80. I don't know. This is still bothering me a little bit. What about a width of 2? Okay. All right. So now you'd go 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91. Right? You got 6 intervals again, but this is a little bit more what we're sort of used to counting by. People don't really count by 3 so much. Plus, where we started this, It got kind of wonky there. Wasn't that helpful? But just for the sake of argument, what if I went all the way next to the width of 5? All right, well, now I would go 80 to 84, 85 to 89, and then 90 to 94. But it condenses too much. With a range of only 10, that's quite a condensing. So how about let's do this. Let's do the width of 2, right? If we were in class together, we'd let you vote, but I'm voting without you now. So we're doing this. So let's go with the width of 2, starting with 80 at the bottom, all right? So how you would start with this would be, you'd go 80 to 81. So, because 80, 81 is the width of 2, right? 82 to 83, 84 to 85, 86 to 87, 88 to 89, 90, 91, just like we did in the example. All right, so now let's go back to our original data that we had. We're grouping it now. All right, so here, the top part is we've got 90 to 91. That's going to be 2. Okay, so 90 to 91 is 2. Then we have to do 88 and 89. So 88 and 89 is 6. So I put a 6. 86 to 87 is 3. 84 and 85 is 4. Okay. 82 and 83 is 3. And 80 and 81 is 2. Okay. All right. So now I want to make sure that I've got everything. And so you add this up and you see that you've got 20. Okay. Your N is 20. All right. So our relative percent, we can just, sort of go over here, but these aren't going to be the same because, right? So it's not a carryover. It's just we start with 2 out of 20 is 10%. 6 divided by 20 is 30%. 3 divided by 20 is 15%. If you don't remember why we're dividing by 20, this is just giving us what sort of percentage out of all of our data is represented by this interval, right? So 4 divided by 20 is 20%. 3 divided by 20 is 15%. 2 divided by 20 is 10%. So I start at the top. I go 10%. You add 30% is 40%. You add 15% is 55%. 20% is 75%. 15% is 90%. And then another 10 gives you your full 100% of all your data is now represented in the graphic. All right. So that's how to take simple frequency and turn it into a group frequency. Okay.